All right, so we're going to continue with where we left off. So we're still exploring our data set of home sales. So let's create a list. Let's call it my columns. We're going to include city this time. Let's do a pairplex. Remember, we're looking at historical home sales. So in this, if you were to actually have the original data set, you would have home sales, you'd have active, you would have withdrawn, and you would have expired. We're only dealing with actual sold properties. So these would be in the public domain, and it's been actually sold. But we're only looking at 3 cities. We're looking at Charleston, South Charleston, and Dunbar. So let's actually look at the city. So we'll include Hugh. We'll set Hugh. So we're going to do another pair plot. We're going to look at the main ones that we're looking at, excluding Bath's total, or I'm sorry, Bath's full and Bath half. And we're going to look at it with respect to the city to see if there is maybe if the location does affect the any values, or maybe if there's a pattern. Maybe if Charleston and Dunbar or South Charleston are maybe valued a little bit differently. So here, along the diagonal, we still have a histogram. You can see that maybe the homes in Dunbar maybe are a little bit cheaper than homes in South Charleston, but maybe it's not. Maybe there's other underlying factors. Maybe they're just smaller. You can kind of see that maybe they're just smaller over here. So that could be one explanation. Something else, if you're going to go another step further, we also have construction. If we look at our data frame, we also have construction. So we could look at that as well. However, when it comes to our construction column, we have a lot of we have a lot. So maybe you'd want to break this up a little bit differently. Maybe you'd want to just group bricks together. Maybe you'd want to group aluminum together, and so on. That way, because I mean, you only have one log, only one stucco, only one stone, and so on. So that you'd want to do something to it. You wouldn't want to use it in that format. You want to clean it up a little bit. But anyway, so this is our data, and we're trying to estimate current price given our explanatory variables. It seems like square footage would be a good one. It's 83% correlated. It looks fairly linear. It looks like it opens up a little bit, which could pose a problem. But for the most part, it seems pretty linear. Maybe it's like the number of bathrooms seem to be a good relationship. Seems like the number of bedrooms you would think would be a good relationship. Maybe it is in another situation, but here you can see that it's not necessarily linear. And you can see this as well. It does seem fairly linear with square feet. That would make sense. So if we go over here, we can say if they're 73% correlated. If you include another bedroom, that would be more square footage. So if you did an add-on, if you ripped out an attic and you put up drywall and it became a bedroom, then the square footage increased, as well as there was a new bedroom. So that also increased. So in the next video, we'll start our regression analysis portion.